Hello, my name is Jim Mullaney from SciTech Process Solutions. Today is Thursday, April 28th, 2022. Today I'm doing a video source inspection on a fully remanufactured 4300S spin rinse dryer. This video will be uploaded to our YouTube channel, so we do not give our customers names. However, their PO number is 780-14778, and they're an international customer, non-US. This customer, what they've done is they're trying to copy an existing process that's done by another one of their sister sites here in the United States, where they're running 300 millimeter wafers, those are 12-inch wafers, utilizing a custom a low-profile cassette, as you can see right there. This cassette and rotor is not the one that's actually being the final shipment with the machine. It'll be a temporary shipment. So the customer actually had us design a cassette that had larger dimensions between slot to slot. They want to match a fob they have, and they're going to be working on doing a transfer from the fob into the cassette. So we did a special engineering design, and that is being, so the new rotor is a little bit longer because the slot widths are wider, slot to slot. But the customer, to save some time, we asked them if they'd like to take a regular cassette for 300 millimeter and a regular rotor. They can use these to start their processing until we can ship them the new rotor and the new cassette in the next few weeks. But the machine this is their machine. This machine is upgraded with the state-of-the-art SciTech Slick Device Controller, the most advanced controller we feel in the world. It's proven, and we have wafer fabs everywhere converting all 100%. This system traditionally handles high-profile 8-inch wafers. That's what a 2300 bowl does because it's 15 inches. But with this special design low-profile cassette, you can run 300 millimeter. Usually with 300 millimeter, the RPMs are more limited compared to a regular spin rinse dryer. We have these at a max of 1200 RPM. This system has gone through our complete remanufacturing process. In fact, if you didn't know, you would think it's brand new, like all of our other tools. What I'll go ahead and do is start the tool. It has about approximately about a 9-minute run. We'll go ahead and start the process, and then I'll talk about our remanufacturing and our support. So the cassette and wafers are loaded in. I simply hit start. Traditional process is a rinse. It's a 4-step process. You have a rinse, which you see now. You'll then have a short purge after the rinse, which blows all the DI water out of the nozzles. Then you'll go into dry 1 and dry 2. In the past, dry 1 is a high RPM and dry 2 is a lower RPM. Because again, we're minimizing the RPM to 1200, it's not near as hot. And it uses centrifugal force, hot into blanket heaters, and then to dry all the substrates. So, while we're just a quick view here, so we're pretty busy in test. Here's another, this is called the 4400. This is another customer. This is the US, it's doing 300 millimeter. We're going to have this one in, well, it's actually in test. We just took the poly off. This is what we do before we put the poly on. We're doing all of our debugging and testing. We have a couple other small tools, 100 millimeter 4-inch tools here. And we also have this system. It's a 8-inch. Actually, this is an 8-inch system that's going international also, to Europe. They're only running 6-inch, but all their systems they're buying are 8-inch compatible, as there's obviously a huge wave of wafer fabs that are 4 or 6-inch that are upgrading to 8-inch for just capacity reasons. So we see that quite often. In fact, the biggest market we're finding right now is for the 200 millimeter. Even if the tools or the customer doesn't run 200 millimeter, they're buying the tools to be 200 millimeter ready. The nice things about our spin rinse dryer is all you do is change out a simple rotor. It takes 2 or 3 minutes, and you've gone from 150 to 200. We also offer, that customer that I just showed you also is running 100 millimeter, where we have inserts that slide in, so you can take a 6-inch rotor, with 5 seconds, slide an insert in there, and now you're running a smaller size, i.e. 100 millimeter. Okay, we got about 9 seconds. I'll let it go through these steps, and then I'll go into our remanufacturing process. Okay, now we're going into the purge. It's a quick 10-second process. Green's good. The N2 valve is open, the purge valve is open, and the low pressure is open. And now we're going into dry 1. This is a 2-minute process for at 1200 RPM. You have your N2 on, you've got your bowl heater on, you've got your N2 valve on, you've got your low pressure purge. Run nice and smooth. It looks kind of weird because of the offset of the wafers, but it's smooth. There's no vibration. It's great. All right, while we're doing that for the next few minutes, it's kind of boring just watching it spin. So in our remanufacturing process at SciTech, we can either do remanufactured tools or brand new systems. We have all the parts, all the bowls, everything done. So in this case, if it's a remanufactured system, the system is broken down. We have build sheets that review what the new build is going to be. It's built up. We send all the parts out for electropolishing. We have a very detailed remanufacturing report I won't go over. We send it to customers so they have it as part of our proposal. But after the parts are all reconditioned, we start the dry build, we call it, in our manufacturing area. Once the head has been built to the dry build mode, in fact, this would be kind of what a dry build mode is. It's just the head assembly itself, all rebuilt, and then when if there's a QC done in our manufacturing, if it passes and it comes in like this to wet test, we hook all the DI water, set it all up, do any debugging. We have a second QC come review it to make sure it's good. Then it goes through about approximately 50 process runs without its final configuration. If it passes that, then all the poly gets put on for the final configuration like this. That's where we have to debug for any noise in the polypropylene, because you have a lot of pieces together and they have to have a nice tight fit. After it's in this system, it then runs for approximately 50 more process runs, and then sales is notified for us to do our videos. Also in the Slick Device Controller, we have our light indicator. Green's good. It means you're running process. You'll see the color change when the process is over and when we're idle. We're now dropping down into dry 2. That's going to be the 5-minute dry. We're down to 500 RPM. So this is where we just use everything's still working, except for you also have in dry 2, you have the anti-static module come on, right there. The bowl heater, blankets, there is thermostats on them to open and close as necessary. If it turns amber or yellow, that means it's open because it's at temp. And then if it falls below our temp spec, it will start heating it back up again. So that's what that looks like. It'll be green half the time or amber half the time. So that's how so that's our remanufacturing process. On this, all these rinser dryers, this rinser dryer, we have 100% spare parts: motors, servo amps, bowls, door seals, windows, controllers, ACR valves, rotor stoppers, everything and anything on this tool we can sell brand new. Our company is 25 years old. We are the U.S. leader in spare parts as a non-OEM for all of the spin rinse dryers. At SciTech, we also purchased 2.5 years ago the Vertec product line. We are the OEM for Vertec now. It's actually doing very well. I see out in manufacturing we're doing 2 8-inch systems right now, double stacks that are being built up. We are now the OEM for Vertec. So to see what parts we have, if you go to our website at scitechprocess.com, on the left-hand side you'll see a bunch of buttons. The first buttons are all spin rinse dryers. The first 3 are the systems. This is an S model, it's in SAM. We also have one that looks like this, which is called the F model, uses a different motor. And we have what is the traditional ST. The next 3 buttons are all the spare parts. We have 100% spare parts on this system, the older systems, and the F models. No issues, no concerns, we have it all. Besides that, we also do complete repairs. We do controller repairs, servo amp repairs, motor rebuilds. In fact, one of our biggest markets is people sending us their rinser dryers. We get multiple rinser dryers weekly that we are then refurbishing for customers. The nice thing about our refurbishment process is that when we do a customer's tool, we build it up to the same standards as if we sold the tool. So they get a system. We don't change the poly unless they want to pay for that. So if it's stained and so forth, that's their issue. But our remanufacturing process, we have many customers that they just send us a system goes in, a system comes out. It goes in, goes out all year long. And every week we get a new system from those customers. Right now I think we probably have, 7 or 8 refurbs in-house that we're working on from the last few weeks. We also have some of the SAT and SST parts. We're limited on those because we're not really, that hasn't been our market share. But as we acquire tools, we get a lot of spare parts that are new. So you can see that. What we also do at SciTech, the spin rinse dryer technology is about 85% of our corporate business. It's our mainstay. It's what we do. We are the world leader, we feel now, on rinser dryers. We also do metrology tools. That would be KLA 10-core particle counters, prometric systems. We have a Nano 210 that we're shipping out in a couple days. It's actually in our other side of the building. SciTech was lucky enough with our growth. We purchased our first building in 2006, and then we bought a second building 6 months ago where we knocked through the walls, so we've expanded to 15,000 square feet now in our facility here, not including our offsite warehouses. We also do vapor prime ovens. On a regular basis, we have customers send us their Cyborg, Millipore, IDI pumps, mostly Cyborg and IDI nowadays. Millipore, not too many. They're easier pumps to work on. We also do control systems. That'd be the controllers for those, and so forth. We do high and low power microscopes. You'll see those on our website. So we have a wide range. What we don't have in final test here is normally there is a high pressure mask or wafer cleaner. That's your Ultra T, K&S, or Ultratech single wafer or mask scrubbers, high pressure and brush. We have a couple. We always have 2 or 3 in stock, and we're normally building one. We ship about depending 4 to 6 a year, depending on what the year is. About every month or 2, we're shipping one out. They stay in final test for about 2 or 3 weeks. So we got 30 seconds left. So at the end of this process, it's called the RSP, rotor stop positioner. It's mounted in the back. It'll have, it comes out, it'll shoot out. It'll roll against our back cam assembly to the home position. We call it, it'll be 12 o'clock. Once it goes to 12 o'clock and RPM hits 0, I'll hear the door release. See, the door's locked right now. You probably won't be able to hear it because it's not that loud, and then I'll be able to open it up, and you'll notice the light changes. There we go. We're breaking down. I heard the RSP fire, we call it, actuate. And there we go. Okay, I just heard the door release. So I'll open the door in a second, but I want to show you. At the end of the process, it gives you an update, a complete successful process all the times. And if there was a problem, it would give you an unsuccessful run and there'd be an alarm. You can clear that by clicking that. You can open the door or clear it with a stop. I traditionally just open the door. There you go. If there was amber, so the blue light meant open the door. Amber means you're now idle, waiting. If there was an alarm, that would be blinking. And here's all the alarms in our system. The door, if the door had a failure, the anti-static. We're the only company we know that has real-time anti-static module monitoring. It's called it's our proprietary DDL program that monitors the anti-static. Most customers don't realize when their anti-static modules have gone bad until they all of a sudden start having higher particle counts and they have to work their way back to find a spinner and strier. Our system will notify you of that module going bad, which is a very key thing. Okay, I like to feel for heat, nice and warm. I always get worried about 300 millimeter wafers. Okay, they look good, warm and dry, looks nice, beautiful. We put these back in. Alrighty, perfect. There we go. Brand new bowl, looks fantastic. The machine looks beautiful. Okay, so that will conclude our video source inspection today of a fully remanufactured SciTech 4300S spinner and strier, upgraded with the slick device controller, set up for 300 millimeter substrates. Again, that cassette and that rotor will go temporarily, but the customer will not keep it. We'll be sending their new rotor goes out about this far because it has a wider dimension between slot to slot. If there's any questions, you can feel free to call us at 916-797-9000. If you're on our website, again at scitechprocess.com, any page when you do searches of any tool, part, etc., you can click contact sales. You can put in a couple simple things. We get notified via email and we get back to you.